Let's get started. So far we talked about the problem, and this is what I think is a very good solution. It's been in place at Bloomberg for more than a decade, and things haven't changed much. As I said, this presentation that you're seeing is the same presentation I gave 3 years ago, and yes, a few things have evolved, but basically this is the same thing we've been doing. It's not a new idea. It happens to be a very good idea, but it's not a new one. So I don't want anybody to think that, oh, this is crazy talk. It doesn't, who knows? No, it works, period. So with that said, what should happen if the client misuses library code? What should happen to that poor soul? As an application developer, we should be fired? Maybe. Be more careful? Absolutely. Have tested more thoroughly? Almost definitely. Ask the library component to warn us? How? Please don't say return status, because we know from last time that's not what we want to do. Okay, as library developers, should we document our code better? Should we try to detect undefined behavior? Can we detect all undefined behavior? Remember for last time? We can't detect all undefined behavior. How much CPU of our client should we spend trying to figure out whether the client called us out of contract? Answer, less than 5%. How many people think we should spend less than 5%? Okay, look, excellent. How many people can afford 5 to 20%? A couple of, okay. Anybody able to afford more than 20 but within a constant factor? Too much? Because if you don't run in optimized mode, that's what you're doing. Okay? What about sky's the limit? Just bring it on. Okay, so there are different opinions here. As library developers, what should happen if we, in our library code, detect client misuse? What should happen? Be fired? Actually, that was a problem for a long time. You're not supposed to do that because what are you going to do if you do? What should you do? We don't know. Okay, ignore it and proceed on. That is probably the worst thing you can do. Return immediately but normally. That is also about the worst you can do. Immediately terminate the program. That's an option. Throw an exception. That's a possibility. Spin waiting to break into a debugger. And is that a bad idea? What about something else? Maybe there's something else good to do. By the way, we have some chairs down at the front if you guys would like to come sit down. No worries. All right. How do we as an enterprise decide what to do? As an enterprise, it depends, right? How mature is the software? Are we in an alpha, beta, or production mode? Is this a performance critical application, like a heavily threaded environment where we really, you tilt the scales of the performance and the thing goes out of whack? Is there something sensible to do even? Maybe there is. How about we detect a bug and we save our client's work in the editor before we just crash? That's not a horrible thing to do, actually. Okay? Log the error or send a message to somebody. Get this thing solved. And then who should decide? Now that's another thing. Who in the enterprise should decide about these things, right? First, they have to decide what happens if a precondition is violated, and the second one is, what happens if a precondition is violated is the second one. The first one is how much time we should spend. So somebody in the organization has to make these decisions. One possibility is that it's the reusable library component developer. That's the person who has no idea what's going on in the higher levels of the program, but they wrote this reusable library, and they're going to make an arbitrary decision as to how much effort the client wants them to spend doing this. Okay, that's one possibility. You can tell by the way I said that it's not probably the one I'm going to suggest, right? The second one is the developer of the immediate client. This is the person that has the unique distinction of being the one who caused the problem in the first place by not reading the manual. So the third one is the owner of the application who is responsible for building it and owns main. Of these three, which one do you think it is? 1, 2, or 3? What do you think?
1, 2, or 3. You got A, B, or C.
What did I do?
You're A, B, or C.
Oh, I have A, B, or C. That's what I meant. A, B, or C? All right. I happen to agree. I think that A is a bad choice and B is absurd. So C. And there's something good about that. There's really something good about that because everybody in this room could be that person. That's awesome. Okay. How are we going to do that? So the high-level requirements are we need to make it relatively easy for an application developer to make some choices. How much time roughly to spend looking and what to do if such a thing is detected. Then 2, we need to make it relatively easy even for higher level developers to use this same stuff. In other words, it can't be so difficult for the library developer that they just say, you know, it isn't worth it. Because, yeah, low-level library developers are like this. But higher-level ones and application developers should be able to use this very same thing. So those are the requirements. Now, plan part 1. We're going to provide 3 kinds of asserts. And by the way, we have a distribution. And this symbol BSLS, the BSL stands for Basic Standard Library or BDE Standard Library or Bloomberg Standard Library, depending who you're talking to. But basically, it's also a recursive acronym. And then the additional letter tells you which package in that package group that this thing lives in. So that's where it comes from. Don't worry about the name. It's a placeholder. And for standardization purposes, whenever something like this might occur, we'll talk about that later, it'll have whatever name is appropriate. So don't worry about that. Anyway, 3 kinds. And by default, we'll have the optimized one, cost you less than 5% of your CPU. The regular one, the default one, will be 5 to 20%. And these are approximate numbers. No one is going to go in there and measure it precisely. And the third one will be more than 20%. And so this is the idea. Just in rough terms, we know what a C assert looks like. We're going to give you more than one choice in your library. And I'll explain how this looks in a moment. Plan part 2 is we're going to provide a global callback facility. So absolutely where anybody can specify what they want to have happen. Now, this is the structure of that particular callback. And we're going to have 3 off-the-shelf failure handlers. One of them is going to be fail abort, which prints and terminates. One is fail throw, which throws a standard logic error or something else, depending. It might be something derived from standard logic error. And the third one is fail sleep, as I discussed before. And that might be the right answer in some cases. But this is something that the application owner gets to decide at runtime before they go into all the other things that they do. So that's the high-level specification. And turns out that because we've been going through repeated discussions in the standard committee, some good suggestions came out. One of them is to use a struct. So should we ever want to add a 4th field, and we do, it won't require a breaking change to everyone else. So this was a great idea, and we're doing that. And within the next week or so, our open source distribution will have that implementation change, I think, available about a week. All right, so example, using BSLS assert. Suppose I have our mathUtil.h. Okay, we have a struct mathUtil, and I happen to be one of these old-fashioned people that like to use a struct and a static function in there because it's a unit, it's a node, it's not something that can grow indefinitely, and there are a number of other wonderful properties that this has that namespaces at this level don't, but that's another story. But for the purposes of this, this is just a plain old C-style function, factorial, and I picked it because everybody knows what it is. Here it has a contract, and you can see in there that there's a precondition that says, and I'm not saying this is a good contract or anything about it, I'm simply demonstrating how we would use this here. It's saying that n has to be between 0 and 100 inclusive. Okay, so what do we do to use this? So in our CPP file, we include our math.h, we have our function implementation, we include BSLS assert.h, and we put these two assertions in here. We do it on the same line because it's a range. Otherwise, we would always do them on separate lines. But in this particular case, this is the way we do it. And that's it. That's really all she wrote. Put the code that we would have had before there anyway. Then, what do we need to do? My client wants to use this, so they include mathutil. There's some function. It calls the factorial function out of contract. Then we compile this thing, link it with the BSLS assert.o, and run it, and we get this. That's what happens. Not too bad, right? I mean, the point here is it's extremely easy to use. It does what we want it to do, and it does it without affecting the interface, because this is not something we want to talk about with immediate clients. This is none of their business, right? We're not going to say what happens with this, because it's undefined behavior to them. They don't know. Okay, so I want to be clear. This does what we want it to do. Exactly. Okay, let's talk about BSLS assert safe. We have a different one here because these checks are going to be, relatively speaking, more expensive than the default ones. These are the ones that are over 20%. And so let's say we have our square and class square public, and it has a width, okay, and it has a set width function, and the behavior is undefined unless the width is non-negative, okay? Now, because this is such a small function, we make it inline. When we make a function inline, it's typically because it's very fast, and any check, no matter how trivial, will not be insignificant. So in this case, even though checking is very inexpensive, relatively speaking, it's expensive. So we use BSLS assert safe, which means that this is an opt-in. It's not the default. You have to ask for this check. If you don't ask for it, you don't get it. Okay? But it's your app. You get to ask or not. And when I say when you ask for it, you don't know what you're getting. You just know that you're giving more of a budget to look. But it's up to the library developers to figure out how to spend your budget optimally. So again, if somebody says, okay, I'll give you 10% of your time to spend on testing. You're going to spend that 10% of your time doing the best tests you can. You're not going to say specifically to the person paying your salary which tests you're doing. They trust you to do the best tests you can with 10% of your time. You say, no, I can do 20. You have 20% of your time. Oh, well, then I can do more. That's the idea. So it's on the library developer to use that checking budget, that verifying budget, wisely. And what I mean is runtime. I'm not talking about development time. Okay, so in this case, we have a client. Client includes its own header file, of course. Then it includes our library square, some function, creates a square. Of course, we want to set it to a bad value. Then we compile it, we run it, and we get this. This is not rocket science, right? The point is it's that simple. Which assert should we use? So there are three possibilities. There's BSLS assert safe. This is expensive checks. There's BSLS assert, which are inexpensive checks. And then there's BSL assert opt, which are the kind of checks you want to leave on even in an optimized mode because they're that important and that inexpensive. So the rule of thumb guideline is you don't really use opt much at all, and you use, for inline functions, you use safe, and for non-inline functions, you don't use safe, you use the default, because that seems to work, and the criteria seems to be about right like that. You always have the option to do something different if, for whatever reason, your check in the CPP file is particularly expensive, then you would use a safe assert. All right, so example 3, using BSLS assert safe. I have this class kPoint. kPoint has a constructor, and it says behavior is undefined unless, and we've got these conditions, okay? So here's our inline function, and we put in our appropriate asserts to explain how we solve this problem, and that's it. That's all you have to do. Now, how about our hash table? Our hash table has a resize function. Resize function's pretty heavy. Okay? So adjust the size of the underlying hash table to be approximately the current number of elements divided by the specified load factor. Behavior is undefined unless 0 less than load factor. Okay, so we have our resize function. We have our include our in our hash table.cpp, which, because it's in the CPP, we say, yeah, I'm going to use BSLS assert. It's not going to be particularly noticeable. We don't do opt because that's overkill. If it's optimized, this would be just silly. But we certainly want it because it's not expensive, and in a default build, this is perfectly reasonable. Do you get the, I'm wondering, does this make sense? This is not supposed to be hard. The other stuff was much more exciting. This is much more practical. This is just done. Okay, next one, how about BSLS assert opt? Well, we can imagine, say, a trading system where, doing something really stupid could cost the company its whole everything, and has happened before. So suppose we have this really silly function called execute trade, and it takes a scaling factor, then has this perverse contract. The behavior is undefined unless 0 less than scaling factor and 100 evenly divides scaling factor. So, okay, those aren't expensive checks, and I know this trading system thing is expensive. I mean, it's very, very costly. And so because it's in the CPP, because it's execute trade, which is really important, we're going to make sure that we check this every time, even in an optimized build. Who gets to make that call? The application owner. No. The library developer gets to make the call that it's this, and the application owner even then could say, no, I don't want to pay for anything, because application owners are like that. But the idea is, even in an optimized mode, this would be on unless you really complained bitterly. So that's the idea. We want to make it very easy to use right by default. All right, here's an example of fail spin. We want to use a different handler. Okay, so I've got this main, and all the useful work goes here, but I'm going to set the failure handler here, and if something goes wrong, I'm going to want the behavior when something's detected to be out of contract to do this thing. So I call this execute trade and compile it, and what do we get? It just sends something to the console and waits. Okay? All right. Now, remember I told you last time when we got started that Scott Myers saw this talk in 2011? And I got to this slide, and later afterwards he told me, what was that stuff you just talked about there? That's totally out of place. Move it. So I did something different. Okay? That's why I added that, because Scott told me I should move it. Okay. There are two separate notions of undefined behavior. I know I'm on thin ice. Watch this. Okay? There's language undefined behavior. I'm going to call that hard UB. And I know there are people in this room who really don't like qualifying undefined behavior at all. But unfortunately, sometimes we got to do what we got to do. So language undefined behavior is hard undefined behavior, and hard undefined behavior is serious stuff. Library undefined behavior is soft undefined behavior, and it's not as serious yet. With language undefined behavior, anything can happen. Your cat could get pregnant, right? Oh, crap. All right, it was spelled worse before.
Anything could happen. My name could be misspelled.
I'm going to fix that right now. You guys have to wait. Why? This is real. Okay. It's all good. I have to remember to save that, but it's all good. So as I was saying, your cat could get pregnant. By the way, that was really more undefined before. Now it's defined behavior. So, but if you have, with a library, a contract violation, which is soft undefined behavior or in a library, Nothing dire's happened yet. Not yet. But if you don't do something, we could wind up in the red zone, and then the cat, when I said the cat was getting pregnant, you did this. I really didn't know what you were talking about. I was really scared. Okay. All right. Anyway. So anyway, soft undefined behavior is relative, right? If you don't know the implementation, then soft undefined behavior could turn into hard undefined behavior because you don't know what you're doing and it could be all bad. But if you do know the implementation, you may be able to navigate around hard undefined behavior using certain kinds of assertions, namely BSLS assert. So let's take a look at this example. Here we have a string, and the string is not supposed to have a pointer passed in. Remember we said unless it says, a null pointer, unless we say something, right, and I put it in here, the behavior is undefined unless string is null terminated. But implicitly, we didn't say what would happen if string were null. Therefore, it's undefined behavior from a contractual point of view. But it's soft because in a safe build mode, you never reach the point of hard undefined behavior because the soft undefined behavior is intercepted, and you never get to that fatal point. And the compiler doesn't think it's going to get to that point because the compiler is smart enough to know that there's a possibility, and in fact, a fact, that it isn't going to happen. So this is perfectly legal C++ code, and no compiler has the right to do anything about it because it's fine. Now, the person who called the function out of contract should be dealt with, but the owner of main can intercede before anything dire happens. So I just want you to see this. We'll try it again. Here's another example. And you can see that what happens is before we get to the point where we're assigning to a string something bad, we intercede and it's okay. You see this? Do you see the distinction? This distinction is actually very important because when we say undefined behavior, we always seem to mean hard undefined behavior, right? So we have to be clear. We have to set the parameters in the vocabulary. So say, is it library undefined behavior or is it language undefined behavior? And it's shorter to say hard UB and soft UB when you're making that distinction. Otherwise, please feel free to say language undefined behavior and library undefined behavior also. Or the red undefined behavior and the green undefined behavior is also okay. Anything you want. So now, the thing is, we tend to pass things in by pointer. If you pass something in by reference, I've heard conflicting reports. Can you actually pass something, a null reference in to a function and do anything with it before you've already encountered hard undefined behavior? I've heard it both ways. Does anybody know the answer to that question? You can. You can pass, okay, now I know in practice you can, but I wanted to know by the strict letter of the standard, can a compiler say, nah, sorry, you've left the realm? No. Okay, fair enough. However, if we pass it by pointer, there's no question at all by anybody that this is perfectly soft until we get to the point where we intercept it with our assert and go somewhere else. We're going, right? Okay, so fail throw explicitly. Here I have a main. I set my failure handler to the fail throw. And then I have my try catch block. And I set up some internal state to be saved in the event that I have a contract violation. Then all useful work goes here. And if a contract violation occurs, I can save my stuff. And I want to make it very clear. This is not even necessarily the best way to do things. There are other ways to do things. What I'm arguing is that this is not something we would ever want to preclude. And we'll talk more about that towards the end. The idea is if somebody wants to do this, they should be allowed to do it. As I said, there are other ways to skin a cat. Okay. Now, I just want to mention, this is not a requirement of this particular package. It happens to be a collateral benefit, And it's also very instructional in terms of talking about technical stuff. Since it's a technical conference, I'm doing that. So support for conditional compilation. We have, well, okay. What I just said, that's actually the next thing. It's a long talk. We have three different kinds of checks in order for us to be able to find out whether a particular assert is active. So, for example, if we want to write some code that's conditional on whether we're at some assertion level, we can in effect use these kinds of macro-like things. They're available in the facility. So, for example, let's say I have a date class, and I'm doing some defensive checks in my destructor, turns out, and when my destructor is in that certain mode, and I'm going to show you in a second, when we're in our safe mode, then I want to check the invariance, so I do this. But if I'm not in safe mode, then I want the compiler to generate the fastest possible code, and so I'll take that out. So depending on my build mode, I'll either put this into the interface or not. You see what I'm saying? And we can use these kinds of macros to facilitate that kind of taking things in and not, as long as we're very careful to make sure that we have compatibility. Now, this is the part I was about to say. Mixed mode assertion builds. Suppose I have, okay, so what are the implications? As long as I have ABI compatibility across my different translation units, then that's not a problem. And so this will not hurt us, because if I build one thing in a safe mode and I build something else not in a safe mode, there's no ABI problem at all. What we do, though, is we do violate the one definition rule. And that is absolutely undefined in the language. So for people who don't want undefined behavior, don't do that. Build your entire system either in safe mode or regular mode or optimized mode, whichever one you want. But if you feel a little bit like having some fun because you've got a huge system and you don't want everything to be built in safe mode, it turns out that on all platforms, this is okay. So again, I'm not telling you have to do it. You don't have to do it. But if you want to do it, you can do it, because it doesn't matter. This is all occurring in what is, in theory, undefined behavior anyway. So you can do what you want. So I'm just going to point out what happens here. You can use this, even though we violate the ODR, for inline function definitions and function template definitions. It's not a problem in a CPP file, but it is a problem, can be a problem. Well, it's interesting, let's put it that way, when we start doing this with inline functions and function templates. So in a CPP file, suppose we have built the client with let's say, optimized and default asserts active. But in the library, we've built it with just optimized. So the question is, when we look at something that's implemented in the CPP file of the library, the question is BSLS assert active? And what do you people think? Do you think that if it's, and I want to make clear what this is trying to say. We're saying we built the client in debug mode, and we built the library in optimized mode, and the assert lives in the CPP file of the library. So now the question is, will that assert fire in this mixed mode build? What do you think? Right. So it's not active. That's the idea. If we reverse those and we say the client is built in optimized and the library is built in debug, then what do you think? Yes. Okay, good. All right, next question. We have an inline function defined in the .h file of the library component. And we have the same situation. We're talking about BSLS assert safe now. So I have BSLS assert opt and BSLS assert active in the client, and I have all three active in the library. In other words, the library was built that way. What do you think? Is the inline function going to be, is the assert in the inline function in the library going to be active or not? Probably not active. Probably not, but possibly. What? Okay. this really depends on what's going on under the covers. Okay? But the good news is it doesn't actually break the code. And whenever you're doing this kind of stuff, you're usually in a beta, you're usually doing some sort of debugging or testing. So this is not a production build. The production build would be built all one way, of course. But I'm just saying, but it's an interesting thing to consider. The reason for this is if you inline the function, and it actually does get inlined in the client was built in a non-safe way, the code that gets laid down in the client will not have this, okay? It will not have it. If we reverse the process and build the client in safe mode, but not the library, it's the client's compiler that gets to pull the thing in, and if the thing is actually inlined, then the answer is probably active, okay? So it just is FYI. Now, for templates, it gets even hairier, because for templates, let's say the client code is built in a debug and the library is built in optimized. Now, it really matters because it's not an inline function. What's likely to happen is the compiler is going to lay down an instance of this thing in the client.o, and if there's also one in the library, the linker could choose either. So what's going to wind up happening is we really don't know. And if we reverse it, we really don't know. The only way that would give it a little bit of spin is if this were a template that was templated on a user type. If it's templated on a user type, that biases it somewhat. Again, the reason I'm saying all of this is while it is tied to the implementation, all of this is okay. Why is it all okay? Because none of this happens if the client calls you in contract. All of this craziness happens when you are called out of contract and you've already left the realm of reason, so to speak. So again, I'm saying this is incidental to what we're really trying to do, but it is nice if you don't have to build your entire system in a safe mode. It's an efficiency. It's an option. Yes? The effect of taking the address of a function, if you take the address of a function, the compiler is going to lay down the inline function, I assume you mean, in the .o of the translation unit, and then the linker is going to have to come along and figure out what to do with it.
They all have to have the same address, right?
Yes. Yes, that's why, by the way, the linker does that, because only one function will be chosen. You won't have different functions in different .os. One function will be chosen by the linker. So absolutely. Okay? Now, I mentioned all of this again. It's a happy consequence of what's going on, but it's not required. Okay, why is it okay to violate the one definition rule? And the answer is because syntactically, there's no problem. The stuff will link. It will work. And it's semantically substitutable with respect to the component level contract. So what we're saying is there is no contract because it's undefined behavior, soft undefined behavior, but undefined behavior nonetheless. So with respect to the library level understanding, which is the wink wink with the owner of main and the vendor that sold you the entire library, if I see something, I'll do what you told me to do. If I don't see it, I don't see it, and that's all you ever had anyway. It's just a little bit more fuzzy than it was before. All right, so I went into that whole thing. If you don't like it, you can delete that whole section. It doesn't change the value of this thing. Completely fine. So I have main. Now, just to show what I can do, because I can set up some global flag, I can set up this handler, I can do something, this is something that I can create, a custom handler. I'm just going to make it up now. I'm just doing some stuff, tweaking it, whatever, and then I'm going to call board. This is what I want to do. Okay? And then you just put it in. Here it is. I can take our failure handler and I'm just demonstrating against some of the functionality, set the failure handler to F, and then invoke the handler, because another function that we happen to have on this is you can invoke the handler directly. You don't have to do it through one of the assert macros. However, the assert macros do in fact invoke the handler under these circumstances. All right. And then that's what happens. So far, so good? Okay. Now, our plan part 1 was to have 3 kinds of asserts that by default we have 5%, 20%, and more than 20%. Okay, so what if we want to be very precise and not let this thing default? We want to build an optimized mode, but we want to set the assertion level exactly. We can do that. We have what these things called overrides. So the idea is you can, on the command line, just put down -d BSLS assert level none. One of the reasons we have this is so we can turn off all asserts during testing and verify that the runtime between assert opt and none is indistinguishable. So that's needed for testing at the very least. It also gives you the power to build in debug mode and turn off all the asserts if you want to. It's up to you. You can do that. You can build an optimized mode and turn off all the asserts. You can set the assertion level to be optimized only regardless of the build mode. You can set the assertion level to be optimized and debug. And you can set the assertion level to be all of them, safe included, regardless of what your build mode is. So if you want complete control, you can do that too. And here's an example. I'm just going to show you here. What we've done is we've said that it's BDE build target opt, so it's optimized code, but I want all the asserts on. That's what you want to do. Here's how you do it. Okay, again, now, sometimes, and this is like a little bit more, sometimes we have binary incompatible checks. We can't mix these. This is an entirely different build. We can't put them together, and the idea is we'll need extra data members in our iterators, we'll need extra data members in our containers. So the container needs to maintain an additional linked list, and the iterator needs to maintain an additional pointer. Okay? So if we do that, we can't mix these. So these are completely different. We call that safe 2. And we put that there because sometimes even safe isn't safe enough. So safe 2 is, that's the everything. You know, just throw everything at it you possibly can. So the example I have here, and I'll just put it up, is we've got this, this function remove all, and if you are in a safe 2 build, and only if you're in a safe 2 build, then you get the extra data member and you actually do this extra work. Okay? Otherwise, you don't. And as again, you can't mix and match these because they're not binary compatible. And that happens to be true of other kinds of build targets. For example, one example would be multi-threading. If you build something that's not multi-threaded, you build something that is multi-threaded, and you try to link the two together, you'll get nasty things happening. Okay, disproportionately expensive checks. This is an arbitrary thing that we've decided. When you have a check that's bigger than the work being done by the component, even though it is binary compatible, we're going to choose to put it inside a safe 2 because we want to be able to use safe mode anywhere without getting really strange order of magnitude problems. So even though if it's not binary compatible, all right. But if it is binary compatible, but it's big O, more expensive, and we're going to do this. And the example was a logarithmic lookup and a check that was linear. That would be an example that would not be in a safe mode build. That's our choice. That's our choice as a library vendor. That's what we do. I hope that makes a little sense. All right, so here's how we would use BD build target safe 2. We have some algorithm, and we say is sorted, and we have is member. All right, is member is logarithmic, is sorted is obviously linear, and so the behavior is undefined unless A is sorted, and we put this in is member. We put in, it's a BSLS assert safe nested within are we in a BSLS build target safe 2 mode. Again, trying to make sure that we don't get any surprises. All right, the client, all they do is just say BD build target safe 2, and all assertion levels in this mode are enabled by default. And you can always override that if you wanted to by saying, yeah, I want to be in safe 2, but I don't want to use anything higher than a BSL assert level assert. You can do that. Again, it's just to have the control. Okay, so to summarize this wonderful section, which I realize is more about coding and less exciting than talking about defensive programming and all these wonderful things, because this just works. Here's the deal. If by default you get the first two, if you say opt, you get one. If you say BD build target safe, you get three. If you say save two, you get three. If you say two of them, you get the union of them. If you say all three, you get the union of them. Or if you pick one of the overrides, you're allowed to pick only one or it won't build. If you pick one, then you'll either get none, one, two, or three, depending on which one you pick. As I said, if you try to pick two of those, it won't build. Okay, we're through that. That was the hard one. Oh, I'm sweating. Any questions? Okay, so let me see if I can repeat the question, which is that correct? The question is that correct? Oh boy. So if you call something out of contract and you don't have knowledge of how it's implemented, meaning you're a client, you're not the test driver, you don't know, you have no right to expect anything, right? Okay, if you're the application owner, you have this. You have a good faith effort to try to detect client misuse to the level of the budget that you specified. And if that's detected, that's an if, because there's no promise to detect it, none. But there's no promise to detect, but if, then yes, then it will call what you said, because that's what I told you it would do and I'm not lying. So that you can count on, but it's a two-step process. First, I never told you I would catch it. So you see what I'm saying? But if I do catch it, I will do that. So you can't rely on anything. But again, if 90% of the time you save your client's file, that's better than none. That's all. Okay, hold on. The reason we do defensive checks is we would love our clients to test their code. Our clients do not test their code, okay? And it is a fact that if you do defensive checks early, you will catch bugs while you're testing your code, and your testing will go quicker. However, if you test your code thoroughly and then put in the defensive checks, they won't catch much because the testing will have already solved that problem. You see what I'm saying? Okay, so it's not that we use defensive checks to save our client's code, right? We just don't want the code to be bad at all. So it's kind of, as I said, it's one of four tools, and they fit together very nicely. And environments where you have awesome library developers and very stressed out application developers, this is a really good way to do business, because at least you know something's going on. It's not a substitute for testing and peer review, and static analysis is just, again, a wonderful thing. So I don't know if that answers the question. Okay, question.
Okay, this should be a really short one.
Sure.
So you're done with debugging, you're confident about the application, this is the final version, but you would leave on assert off, is that correct?
Most likely, because the idea is we almost never use it. We use it in cases where it's really important and it isn't going to impact the performance at all, the overall performance. Assert opt is kind of, oh, that's really important. An example where we do this, when we stream out a date, when you stream something out of process, if you stream out a bad date into a database, it's not just a bug, it's a latent bug that could come back and bite you 2 years later. And that is so important that we leave on assert opt in that case, because it's known to have given us tremendous grief. It's a very selective thing. The other ones we just do without thinking about it. In line, not in line, and off we go. Okay, I think there was, yeah, go ahead. It's very coarse. It's not like it's 20 versus 25%. It's kind of like, none, almost none, some, lots, and go nuts. Those are the categories. That's the best we can do. I could take one more question, and then I'm going to go, unless people are, okay, good.
I was just going to comment on the previous thing. We've come up with an assert system that's remarkably similar, and I haven't been to any of your talks.
Okay, so I shouldn't sue you. Okay.
No, my point is, depending on the life cycle of the product, we have these things turned on. For example, when we do beta testing, we don't turn on the 90% ones, but we have the other ones all turned on. It's an optimized build. And then when we go to production, then we turn on only your super safe.
Okay. So let me just, okay, fair enough. Take a look at these questions briefly. I'm scared we might go over by 2 or 3 minutes. I don't want to hold you guys late, but I do want to try to get through this whole thing. I possibly can. So take a look at these, and in particular this one. This is really important. This is the big message here is they're not the same thing. Hard undefined behavior, cats get pregnant. Soft undefined behavior, cats remain childless. Okay? All right. Negative testing. I'm going to go through this quickly because this is not exactly exciting stuff. If you think testing code is boring, well, testing defensive checks is boring-ger. But I'm going to go through it quickly to spare you. What is a test driver? Okay, for us, it's a file that has main. It's that thing over there. It's a tool that we use during development. It's a cartridge for our build system. What does it comprise? A bunch of assertions. These are different kinds of asserts, by the way. And each test case performs some number of assertions. And there are many different ways to, I don't want to say skin a cat because I feel bad, but there are many different ways to test a component. We happen to do it this way, and it works. And our test drivers are about as lightweight as you could possibly imagine. And they return 0 in success, a positive number of failures, or a negative if the test case isn't found. And what's the user experience? It's quiet in production. If there's a problem, we see something that looks like this. We can turn up the verbosity so we can see a little bit of a trace, and there are other levels. Again, I'm whipping through this. This is what a test driver looks like. Obviously, I don't want you to read it, but you see how regular it is? Test drivers are stupid. That's important. If a test driver is too smart, then, oh boy. You want the test driver to be stupid but right. So we have a lot of rules about this, but this isn't about regular old testing. This is about negative testing. We have a test plan in our test driver. Then we have the setup. We have each of the cases. And then we have the shutdown. And that's what it looks like all the time. The test plan is really important. It tells you after which case you can rely on what has been tested in your subsequent tests. We call that bootstrapping. Test case ordering is chosen based on the class category. And we know for different class categories what the right order is. For example, value semantic types, there are 10 tests, 10 cases, first 10, and we know exactly what goes in each one. And we can just tell you and just boom, and you're off to the races. There's tremendous value in that alone. Okay. In a case, we need to set up certain things like we have a title, concerns, plan, and testing. The most important thing is the concerns. You can't test something unless you're concerned about something. If you're not concerned, then what are you doing? So you look at the thing and you say, I'm concerned that I'm off by 1 on this. Okay, check it. That's what a concern is. So here's an example. I want to make sure that I can do certain things. So here are my concerns, and I just put them down, and then the code looks something like this. That's just a quick idea, ballpark idea. Now the thing is, once we test our code for real, then we want to think about, did we get our defensive checks right? That's what we want to do here. And during the course of this testing, the asserts in the destructor will take care of the invariants. Now we need to go after those defensive checks. Exactly. What is negative testing? Okay? Tests that verify that unadvertised defensive checks inserted into library software to guard against client misuse are functioning as intended. The assertion level build modes in which they are intended to be active. Did I say that right? Okay, so in other words, we want to make sure we did the right thing. And if we don't check it ourselves, we don't do something, it's easy to get something wrong. So we want to make sure we got it right. So why do we need negative testing? It's the silly questions. Why would we test undefined behavior? Well, we've been through that. It's undefined behavior to the client, but it's not undefined behavior to us. We want to make sure we did the right thing. And error handling and error checking stuff is the most notorious code. And if you don't check it, what happens is, I hope people have done this in the past or seen it. I certainly have. You'll have some sort of check, let's say, where some condition never happens. And the condition happens. So you put a print statement in and you say, print, and you put %s, whatever, to print out what the problem was, and you forgot to put the argument. So when the error happens, the code dumps core because you never tested the print statement. And we want to avoid, that's C, of course, dating myself. Anyway, if behavior is undefined, how can we test it? This is all just teasing people because we know that hard undefined behavior, there's nothing you can do, nothing. With soft undefined behavior, there is something you can do because we haven't actually gotten to the undefined part yet. So if you have white box knowledge, you can do this. Just simply, we're going to catch the problem before any undefined behavior manifests. So for negative testing to be successful, we need to be able to invoke it, a function out of contract, and observe that something useful happened. We have to make sure that we don't encounter hard undefined behavior. And of course, nobody wants to do this. I mean, it's late in the day. Who wants to go even talk about testing defensive checks? But if we make it difficult, then no one's going to do it. Absolutely not. So some other concerns. Well, we want to ensure that the contract violation is caught directly by the component under test. So let me give you an example, and not by something else. So part of the thing we're going to do is verify in the testing framework that we have, we're going to verify that the thing that tested it is the component's name .t.c file. We're going to check, because part of the testing is to incorporate in this test exception, we'll call it a test exception, is to incorporate the name of the file that threw it. That's one of the important things. So here's the plan. Create a special purpose test exception. As I just said, component file name, source line number, text representation of expression that failed. So we have all three of these things. That's built in. Now, a fourth one was suggested, the level of the defensive check. And because we've been going through various reviews, now we have a struct that describes what's happening. Well, we're just going to add this fourth thing there. Okay, so this is the information that gets passed to the handler by a struct. Okay? So then we're going to create a test utility component defining a suite of static methods that support these macros. I said a bad word, macro. Unfortunately, all of this stuff is macro-based, not in my opinion because there's some horrible deficiency in the C++ language. It's macro-based because there are very few things that really need to know what line number and really need to know what file this is and really need to pick up that information. So that's part of it. And they need to be able to go away completely if you don't want them. And this mechanism works. And as I said, I don't think it's a deficiency. I think there are very few things that deserve this kind of solution. But I don't think this is one that is any different than what we've seen before with logging and good old C assert. So I'm just saying. But to be determined. Plan for each test driver, what we're going to do is assume that our standard test macro is available in the test driver to process the negative test error. So this is, for our code, we have that assert that we talked about in the test driver. And at the end of each test case, for a function that has a narrow contract, we are going to install this handler. We're going to deliberately put something in and then call our function out of contract. On both sides of the boundaries where the undefined behavior occurs, and then we're going to observe that it did exactly what we expected it to do, even though there's nowhere in the contract that says anything about it. Because we know, as the author of the component, the library author, that this is in fact the case. And we won't worry about testing the expected results because we already did that. All we want to know is, I call it out of contract, it goes one way. I call it right inside contract, it goes the other way. And that's the idea. So here's our factorial example. We're going to add to the end of the test case, set failure handler, and then we set this failure handler. And it's the assert test, specifically failure handler. And then we have some code that looks like this. And what we're doing is we're going to call factorial at -1, which is out of contract 0, 100, and 101. And what does that expand to? Well, it expands to something like this. It's not exactly this, but the idea is we're going to try it. And if it doesn't throw, it's a failure. Do you see what I'm saying? If it doesn't throw, it failed. And then we'll catch it and we'll say, okay, well, as long as it's coming from the right component, we proceed. So this is a case, a special case, where it's good. We called it out of contract and it didn't continue. It did what we told it to do. Life is good. You don't need to use a lot of tests to make this happen. As I said, just this much is enough to make sure that we satisfy our conditions. I'm going through this super fast because I really know we're short on time. So another point I just quickly make is that when something succeeds, it does whatever it's supposed to do. In other words, when it's in contract. When it's out of contract, it doesn't do what it does, obviously, because you can't call something out of contract. So this is implementation experience that this stuff just has to happen. We can't say, if you're not in a safe mode, don't do this work, because being able to sort it out is really much more difficult if you do that kind of thing. Okay, so the observation, to say it again, if a positive test changes state, e.g. allocates memory, it typically must run in all build modes or cleanup becomes too complicated. For example, and then we have this wonderful example, is disabled when when we are in safe mode. This always runs. So fail is disabled because we're calling it out of contract, and it's not, the assert isn't active. The other one, it's in contract. It doesn't matter that it's not active, and we do it. Again, that's an observation. So if we wanted to test vector, we just install this handler. We're going to test this, this particular guy here. So if it's empty, we'll call this. Then we'll push back 9, and then we'll do this, and it'll be just fine. Then we'll push back 42, and we'll do this. Then we'll pop back, and we'll do this, because we're testing the boundary. We're looking to see that the behavior, as it crosses from defined to undefined, is picked up by the defensive check. As I said, this is not particularly exciting stuff, so I'm rushing through it. You get the idea. It's certainly in the component. You can go look at the component, and it gives you exactly what's going on in abundant documentation. But it turns out that sometimes, particularly constructors, we may wind up bumping into soft undefined behavior before we get to the point to check that we have undefined behavior. And unfortunately, to us, the other component, we don't know how that's implemented, and that could change. So we have to do something a little different. So here's a problem, because in the initializer list, we might already be encountering something bad. But it turns out it's not as bad as all that, as long as the other component is in our library and also throws the same exception. And if that's the case, and it happens to catch it in a constructor, the path of least resistance is to just say, all right, for constructors, that's okay. So I'm just glossing over this again because I want to make sure we get through everything, and we're almost done. And there's one little thing at the end I want to talk about. So we address this by adding the term raw, and raw is just forgiving. It says, as long as you throw the exception, I don't care what component you come from, and it looks something like this, and we're happy. This is just a little example of how we might test such a thing. All right, so safe 2 mode only. I mean, it's obvious what we'll do is we won't test something unless it's active in safe 2. So I'm through that. Do you guys have any questions? Here's some questions. And I realize we're almost out of time. We are actually out of time. And what? Right? Question?
Yeah, I have a comment about the safe 2 macro.
Uh-huh.
Would it be a good name for it to call it like safe slow? Is that sort
we could rename it. Let's do this just because we're actually literally out of time, and I want to bring up one quick point if I can. Let me just go through this, and I will stay late, and anybody who wants to discuss this with me for now and for the rest of the week, I'm good. But let me just get this done. Just pointing this out, this is something wise that we can reliably test our own library undefined behavior. The answer is because it's not undefined behavior to us. It's well-defined behavior. It's totally defined behavior. It's our implementation. Just wanted to put that up there. Okay? Now, so late-breaking news. The C++ Standard Committee has adopted a new exception specification construct, noexcept. This is actually 3 years old. It's not that late-breaking anymore. Was added to support move semantics, decorating arbitrary functions with noexcept may yield space speed optimizations. Attempting to throw through a function decorated with noexcept terminates the program for security reasons, I understand. How is this relevant? Why is noexcept relevant to this thing? Later breaking news, Standards Committee was eager to apply noexcept liberally, even for narrow contracts. Now, I'm wondering, do people see why this is at least problematic? Because if you put noexcept on a function that's narrow, and then you want to defend against it, in other words, somebody gives you something bad, you say, I'm going to throw. If it's noexcept, it will terminate the program. So you've removed. Well, again, one of the nice things about not having this problem is it makes testing easier, but it's not the only reason. It's a different thing, and it needs to be understood. Now, the reason that noexcept was created was for move semantics, that we know the history, and it was later observed that it might be reasonable to decorate functions that shouldn't throw in contract with noexcept. And therein is where the dragons lie, and I'm just going to keep going because we're almost done. So this is what happened. We had to come up with some guidelines, and the guidelines we came up with were use it only for move construction, use it anywhere where it shouldn't throw, and it's a wide contract. And the third one is use it wherever it shouldn't throw in contract. Okay? And I really did make a strong case for this, and people believed me. So what happened was we got consensus with this. And this is the state of the standard. So we spent the whole time, right before C++11 shipped, going through and being consistent. We finished a day early. This is what happened. It's done. And it turns out that C++14 follows the same standard. So happily, conclusion, I'm just going to put this out there for you. Not even read it. Okay, so that's just to sum up that. The second one, pointing out that when undefined behavior is undefined. The third one, this is really an important point. Defensive programming means fault intolerance. That's really what we mean. It's not fault tolerant, it's fault intolerant. There's really no way to defend against your own coding errors in your own program, because that's just self-fulfilling. So narrow contracts imply undefined behavior, and I love this one. Undefined behavior is good. Do I really mean that? No. But why is it useful? It reduces costs associated with development and testing, improves performance and reduces object code size, enables practical, effective defensive programming, allows useful behavior to be added as needed. Okay? So that's what we meant by that. And of course, this is what we were just talking about this session. The application owner knows best how much time to spend, what to do if there's a problem. Test assert enables us to do this. We get all the benefits of DP without all the drawbacks. Negative testing, it's part of getting it right. Our BSLS test assert component makes it practical, easy, and efficient. That noexcept thing would kind of put a kibosh on that. Anyway, care must be taken to ensure that we test defensive checks only when they're in the supported mode because otherwise it would lead to hard undefined behavior. Constructors are uniquely problematic. And finally, I think we got this right, and I hope it doesn't dissolve into something different because I really do think that this is a useful concept and paradigm. And finally, if you want to see the current state of this proposal, why does it say 075? That is so annoying. It's 4075, real-time fix. Actually, you know what I'm going to do? I'm going to finish this and then fix it after the fact because we are in a little bit of a crunch time. So let me do that. This is our open source distribution. And finally, this animation took me 2 hours on the plane, I swear. I tried to make this work, and I could not figure out PowerPoint 10 to save myself. And then finally, I did. So that is the end of the talk. I'm sorry I went over 5 minutes. I'm going to correct this. It's N4075. And I will stay up and talk to anybody who would like to talk to me.